7.4, this is going to be in two parts. We're going to start looking at systems of equations, and so you're going to look at page 277 to 280. Now, a system of equation just means that you have two or more equations with the same variables, and your solution is going to be an ordered pair, x, y. So right here what I've got is, here's a graph, and here's one equation that I've drawn here, equation 1. And here's another equation, separate equation. There's one point where these two lines cross right here, and that point is the solution of this system of equations. Okay, and we are going to, in part 2, talk about solving graphically. But I want you to have a picture of it before we start talking about solving it with algebra. So to solve it with algebra, there's two possible ways to do this. The first way, you have two equations. Here's one, y equals 7x plus 10, and y equals 9x plus 38. You are going to set them equal because y is equal to y. And so notice that both of these equations, y is all by its lonesome here on the left. So if I set y equal to y, I can write 7x plus 10 equals 9x plus 38, because that's where the solution's going to be. It's where they're equal, where they're at the same spot. So once I have that, now I can do what we've been doing in the previous sections. I take away 7x from both sides. That gives me 10 equals 2x plus 38. I take away 38 from both sides. That gives me negative 28 is equal to 2x. I then divide both sides by 2, and that gives me negative 14 is equal to x. Now this is only half of my solution. Okay, remember I need an xy pair. So now I'm going to take this number, and I'm going to use, it doesn't matter which one I use. I've chosen the first one. So I'm going to take this number, and I'm going to take my first equation, y equals 7x plus 10. I just rewrote it here. And I'm going to put my solution for x in there, and I wrote it wrong. Oh dear. All right, so x is equal to negative 14, right? Okay,